Hello guys, welcome to our report. For today's discussion, me, Erica Pacarat, and Miss Valerie Colling talk about the or our Earth atmosphere. So in line with the topic, we are going to discuss the composition, distribution, and the characteristic of the atmosphere. So for my report, I will discuss the composition and distribution of our Earth atmosphere, while Miss Colling present the different characteristics of the atmosphere. What is atmosphere? So the atmosphere, it is a shell of gases surrounding the Earth. It is most dense near the surface and gradually thins out the space. So the Earth's atmosphere is so much more than the air we breathe. It is one of the main components of Earth interdependent physical systems. So atmosphere is the layers of gases surrounding the planets and other celestial bodies like sun and moon. The atmosphere is composed of 78 of nitrogen, 21% of oxygen, and then 1% of other gases like carbon dioxide, argon, and other gases. So these gases are found in different layers of the atmospheres like troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. So that will discussing by Miss Colling. So the atmosphere protects the life in Earth by shielding it from the incoming ultraviolet or UV radiation. So UV radiation or ultraviolet radiation is a form of electromagnetic radiation na makuha nato through the sun, and also makuha pod nato from the man-made sources like cell phones, lamps, and other sources or devices na makakos og radiation. So in this radiation, makakakos siya og eye problems through the devices or gadgets na ato ang ginagamit. And then skin damage through a long period of exposing our skin in the sun. And then, so through the help of our atmosphere that protects and preventing us or our planet and extreme temperatures and for the um, extreme cold at night. So the early atmosphere was formed by volcanic outgassing. So this eruption produced a massive amounts of carbon dioxide and water vapor. So water vapor condensed into clouds which rain down for forming Earth's early oceans. So si water vapor is nagarelease siya og greenhouse gas na importante siya sa kay siya ang nag-absorb and siya din ang nagkapagawas og radiant energy nagikan sa sun. So within the thermal infrared range, ang init na nagkakos ng greenhouse effect. So ang rule of ni radiant energy is siya ang murag nagasala sa heat na ginabuga sa sun and para dili siya direct ang init sa atua. So the water vapor is composed or nagakompose siya og water vapor molecules na naga-discharge or emit heat in all directions. And also, water vapor is the second source of warmth in addition to give sunlight at Earth's surface. And then, photosynthetic life takes hold in the early oceans, producing oxygen in the atmosphere. So, photosynthetic or photosynthesis, isa po ni siya sa importante na cycle sa ato ang atmosphere because siya pod ang source of oxygen na kinahanglan nato as human and also for the all living organism. So here's the modern composition of the Earth atmosphere. So our atmosphere is like a blanket, just like a warm blanket protects us from the cold night air, and our atmosphere surrounds the Earth and protects us from the human effects of the sun. So as I said a while ago, so our atmosphere is just a warm blanket that protects us in the direct heat of the sun and for the um, cold nights at at uh, cold nights temperature. Then so these are the modern composition of Earth atmosphere. First is the solids. So solids like dust, ash from the volcanic eruptions, and then bacteria through the through getting an aerosolization from various surfaces exposed to our or to air currents. And then second is liquids na makuha na to through water. And then third, modern composition of atmosphere is gases from the air like nitrogen, oxygen, and other gases that that we get through air. So here's are the main gases of our Earth atmosphere. The first is the most abundant gas, which is nitrogen, which has 78%. So so nitrogen is one of the building blocks of life. It is important and essential for all plants and animals to survive. And also nitrogen is essential for the growth and reproduction of the both plants and animals. And then second most abundant gas, which has 21%, is the oxygen. So humans and animals takes oxygen gas in breathing. So the oxygen is not the main components of our Earth atmosphere. That comprises 21% of the total kumpara kay nitrogen na merong 78%. But its role in the survival and many forms of life elevates its significance kay oxygen. So like for our respiration that gives energy to us to breathe and stay alive. And then the third main gases of Earth atmosphere is the other gases like argon, carbon dioxide, helium, methane that has 1%. Um, so other gases like argon that has 0.09%. So it makes up or comes from the decay of potassium in the Earth's crust. It is an unmoving gas, which means hindi siya nagre-react with the other chemicals like carbon dioxide and helium and neon and etc. And then the other gases in the atmosphere is carbon dioxide, which composes of 0.4% of the atmosphere. So the role of carbon dioxide is in the atmosphere is very crucial to plants because plants use carbon dioxide to make food and release oxygen for us human. So in addition lang, so napatay ginatawag nga human impact that can cause for our atmosphere na dugay siya maka-absorb and maka-release og clean air, and other sources na makatabang sa atua sa mga tao, and then sa plants, animals, and then sa atong environment. So these are the different human impact for our atmosphere. So first is the pollution. So pollution through the smoke or gases that comes from the car, trucks, factories, and sources na makakos og pollution sa air, and then deforestation. So sa deforestation is kung wala na yung mga puno na nagatabang sa tua na dili direct na maigo ang sunlight, na makakos og skin damage, and then through the deforestation is mo increase po ang carbon dioxide in the air, and kung wala na puno na nag-absorb dire, and then burning fossil fuels. So sa burning fossil fuels is na nakakos or nakakakos siya og nitrogen oxides, which contributes the formation of smog and acid rain. So these are the typical human impacts to our atmosphere. So if we continue to doing this na mga nakakasira sa atong atmosphere, kita gira gihapon ang mag-suffer. That's all my report about the composition and distribution of our Earth atmosphere. So before mag-end ang akong report is nalang ko'y ipakita na video para masabtan jud kung unsa ang distribution and composition of our atmosphere. And then next reporter report the other topic about the atmosphere. Thank you for listening and have a great day.
This is the Earth's atmosphere when viewed from space. That thin blue line at the edge of the planet is all that stands between you and the vacuum of space. The Earth is an approximately spherical ball of rock, about 12,750 kilometers across. And our atmosphere is really a thin skin across the surface of the planet. It's a bit hard to get an exact thickness of our atmosphere because the outer edge gradually fades into the vacuum of space. But most people accept that it is about 100 kilometers across. Almost all of our weather and our experience in the atmosphere is limited to the first 40 kilometers. We can look at the structure of our atmosphere a little more closely in this diagram. Commercial airlines fly between 10 and 15 kilometers up. Military aircraft can fly up to twice that. And above 30 kilometers, all you'll encounter will be a couple of weather balloons. Without the safety of an aircraft, humans struggle to breathe above a few kilometers into the air. The highest permanent human settlement is La Riconada in Peru, and that sits about 5,100 meters above sea level. And although humans have walked on the top of Everest without oxygen, which is nearly 9 kilometers above sea level, they have not been able to stay there for very long. And so it is just these few kilometers of air that keep us alive. Now, I should point out that the examiner will not ask you to recall the dimensions of the Earth's atmosphere. However, it is important for you to have a sense of scale for the planet you live on and the vital nature of those first few kilometers of air. The examiner will ask you about the composition of today's atmosphere, which is a mixture of three main gases. You need to know their names and the percentages of each one. The composition may surprise you. First of all, the most common gas by far is nitrogen and not oxygen. Discounting any water vapour that we might find, our air is approximately 78% nitrogen. The next most common is oxygen at 21%, and the last 1% is mainly the inert gas argon. Now, you hear quite a bit about carbon dioxide in the news, and of course it's carbon dioxide that we breathe out, that plants require for photosynthesis, and that we release when we burn fossil fuels. But in actual fact, carbon dioxide makes up only 0.04% of our atmosphere. Thinking about that 0.04%, we should talk briefly about units. Scientists and examiners may use another unit. 1% is the same as saying 1 part out of 100. And so 0.1% would be the same as 1 part out of 1,000, and 0.01% would be the same as 1 part in 10,000. The examiner will talk about parts per million. And so 0.04% is the same as 400 parts per million, or 400 ppm as it gets written down. Now, you won't be asked to convert between percentages and parts per million, certainly not without the examiner giving you a formula, but you do need to be aware of this unit, as it might turn up in tables, graphs, charts, or in the text of an exam question. There are also other gases in our atmosphere, principally the remaining inert gases. Neon, helium, and krypton all make up tiny amounts of it, along with about 1 to 2 parts per million of naturally occurring methane. Other gases are generally referred to as pollutants, and we'll talk about them in later lessons. So this is the air we breathe, and despite the fact that human activity and atmospheric pollution has made some changes to the atmosphere over the last few hundred years, the actual size of those changes relative to the main gases in the atmosphere are tiny. In fact, the percentages of the common gases in our atmosphere have hardly changed at all for the last 200 million years, and that's all the way back to the time of the early dinosaurs. The examiner quotes the following basic figures: that for the last 200 million years, our atmosphere has been approximately 4/5 nitrogen, that's around 80%, and 1/5 oxygen, that's 20%, and small proportions of other gases, notably carbon dioxide, water vapour, and the noble gases. The examiner could choose to use fractions, percentages, or even ratios in their questions. So it's also worth noting that the ratio of nitrogen to oxygen is pretty much 4 to 1. You should make sure now that you can recall the percentages of the gases in the atmosphere and be familiar with those numbers as percentages, ratios, fractions, and also parts per million for the rarer gases. Take some time now and learn those off by heart, so it will be easy marks to get in the exam. In the next lesson, we'll be looking at where our atmosphere has come from, and we'll be taking you right the way back to the early days of our planet to explain its origins.